Hello friends, welcome to Risingpearl.com. We are talking about series 2 triangles. Today is webisode number 20. Friends, today we are going to learn a special theorem on areas of similar triangles. So let's take a look at what is this special theorem. So like we always do friends, let's first understand what the theorem is telling us. The ratio of areas of two similar triangles is equal to the square of ratio of their corresponding sides. So first thing that we have to understand friends is that this is not about the similar triangle itself, but it is about the areas of two similar triangles. So that means we start with, we have triangle ABC. It is given that ABC and PQR, these two triangles are similar. So we have been given triangle ABC is similar to triangle PQR. This is what is already given to us. So what the theorem is telling us is that the ratio of the areas of two similar triangles. So the area of triangle ABC can be written as ABC. We know that area, we write it as abbreviated form AR. So area of triangle ABC divided by area of triangle PQR. PQR, because that is what will be the ratio of the areas. So the actual area of triangle ABC divided by the actual area of PQR, what this ratio is, this is equal to square of ratio of corresponding sides. So we know the corresponding sides in this triangle is AB by PQ, right? So this ratio, I think we don't have enough space, let's just probably write it over here. So this ratio is equal to square of ratio of corresponding sides, which is AB by PQ square of this ratio. So whatever this ratio is, it will be times 2 to the power 2. And since we know basically that in similar triangle all these ratios are same, that is, right, we have AB by PQ equal to AC by PR, which is equal to BC by QR. We know that in two similar triangles their corresponding sides are always in the same ratio. So the area of the triangle ABC divided by area of triangle PQR is equal to the ratio of the corresponding sides square. So AB by PQ square, we can also say the same thing is equal to AC by PR square, which is also equal to BC by QR square, because all these ratios are same. So friends, the ratio of the areas of two similar triangles is equal to square of the ratios of the corresponding sides. Now that we understand the question or the theorem, let's look at how can we solve it. Now friends, we will start out by simply, so we have got triangle ABC is similar to triangle PQR. So what we do is from point A we drop a perpendicular on side BC. Let's say it intersects here at X. Similarly from point P we drop a perpendicular on QR intersecting QR at Y. Now friends, we know that area of a triangle is equal to half times base times height. That is how we find out the area of a triangle. So in this case, area of triangle ABC. So area of triangle ABC ABC will be equal to, let's write it here, half base is BC, half BC multiplied by AX. AX. This is just a multiplication sign. And similarly, area of triangle PQR. PQR will be equal to half. I think let's not write the multiplication sign like this. Let's mark it as dot, because I think this multiplication sign will get confused with X. So half dot base is QR, QR times PY. PY. So if we are concerned about the ratio, remember we want to find out the ratio of area of triangle ABC by area of PQR. So we divide both. So half and half gets cancelled. So what we have here is BC times AX. AX divided by QR times PY. PY. Let's say this is our equation 1. Then friends, what we do is that now we will, so we have this 90 degree, we have X, we have Y. Now friends, we are going to take a look at this triangle and this triangle. And why, you will see that in a moment. If you look at these two triangles, we know that angle B is equal to angle Q. Why? Because triangle ABC is similar to triangle PQR. So all corresponding angles are equal. And also this angle is 90 degree by construction. So these two triangles are similar triangles. So here friends, what we have is we can express AX divided by PY equal to AB divided by PQ, right? Because these two triangles are similar, we can say AX divided by PY is equal to AB divided by PQ. Corresponding sides are in the same ratio. But now remember that ABC is similar to triangle PQR. So we have AB by PQ equal to BC by QR, right? We actually have, because AB by PQ is equal to BC by QR, right? So from here friends, what we see is that, so in this we have AB by PQ, and over here we have AB by PQ. So from this two we can say AX by PY, this ratio AX by PY is equal to BC by QR, BC by QR. So the ratio of the altitudes, so AX by PY is nothing but it is equal to BC by QR. Now friends, now earlier we have seen that the area of the ratio of the areas, area of triangle ABC divided by area of triangle PQR, we saw this ratio to be equal to BC times AX divided by QR times, we should have put it by dot notation, times PY. But we just now saw that this ratio AX by PY, we can express that as BC by QR. We just saw that, right? When we looked at these two triangles were similar, from there we saw that AX by PY can be written as BC by QR. So we have already BC by QR here, QR, this multiply by, instead of AX by PY, we will write BC by QR. And so you will notice here, friends, we will get BC by QR square. That is, BC by QR multiplied by BC by QR is nothing but BC by QR square. So friends, the ratio of the areas of two similar triangles ABC and PQR, we got this as the square of corresponding side BC divided by QR. And because we know that ABC and PQR are corresponding, they are actually similar triangles, so each of these ratios are same. So we don't have to really prove anything else, because we know that AB by PQ is equal to BC by QR is equal to AC by PR, right? So all these ratios are same. So we have proved that the area of ABC divided by area of PQR is equal to one of the ratios square. So in this case it is BC by QR square, and because all these ratios are same, that means we can write this as AB by PQ square, or BC by QR square, or AC by PR square. So friends, this is how we are going to prove it. Now let us just clean it up and write it how you're going to be doing it in your tests. So we start out with seeing what is given. We draw two triangles. It is given that ABC is similar to triangle PQR. We need to prove that the area of triangle ABC divided by area of PQR equal to the square of their corresponding sides. We drop a perpendicular AX and PY respectively on each of these triangles. We know that area of triangle is half times base times altitude. So we separately write out the areas of triangle ABC and PQR, and then when we divide them to find out the ratio of the areas, we divide them. We get a relationship which is AX times BC divided by PY times QR. We call it equation number 1. Then we closely take a look at the triangles ABX and PQY, and here we find out that angle B is equals to angle Q because angles in a similar triangle are equal, and AXB equals PYQ because both of them are 90 degrees. This and this are 90 degrees, and this angles are equal. So these two triangles are similar by AA similarity rule. Therefore we find out that AX by PY can be written as BC by QR. Now we replace the AX by PY in equation 2 by equation 1. So here we get the ratio of the two areas is equal to BC by QR square. So now since we know that all the ratios are same, all these ratios are same, so we can express the area of triangle ABC divided by area of triangle PQR. That is, we can express the ratio of areas of two similar triangles as BC by QR whole square, AB by PQ whole square, or AC by PR whole square. So friends, hence we have proved the theorem. In the next video, we are going to take a look at some of the questions that may come up regarding areas of similar triangles.